What is a chemical reaction? For an instance, let's say you are cooking an egg. Notice how the appearance of the egg changes after cooking it. Not only do they look different physically, but you have also permanently changed the structure of the egg. Chemical reaction occurs when the actual composition changes, that is, when one substance is transformed into a new substance. You may not know, but chemical reaction happens everywhere. Every day, we witness traces of chemical reactions. For example, when we burn woods or when we bake cookies. But what makes these chemical reactions work? What is behind these reactions? In a chemical reaction, there is a transfer or sharing of electrons. These electrons are what we call as the valence electrons. Valence electrons are the electrons located at the outermost shell of an atom. Like in beryllium, for example, it has 2 valence electrons since only 2 electrons are located at the outermost. When 2 atoms interact, the electrons in the outermost shells are the first ones to come into contact with each other and are the ones that determine how an atom will react in a chemical reaction. Imagine a fast food chain's drive-thru service. We drive through the lane in our car, reach our hands out the car's window, and the employee reaches out and hands us the food we ordered. The arms of the driver and the employee can be considered as similar to valence electrons. A chemical reaction is typically represented by a chemical equation. There are 2 parts in a chemical equation. The reactants, or substances which take part in a chemical reaction, is on the left side of the arrow, while to the right of the arrow are the products, or the new substances formed after a chemical reaction. There are 5 types of chemical reaction. First, synthesis. Second, decomposition. Third, single displacement. Fourth, double displacement. And last, combustion. First is synthesis, where elements are joined together. It is when substance A is added with substance B, so we get a combined compound of AB. For instance, if you wanted to eat burger and fries, so you decided to buy both of them. An example of which is 2 molecules of hydrogen gas plus 1 molecule of oxygen gives 2 molecules of water. Second is decomposition, where a compound breaks into parts. It is when a combined compound AB breaks down into 2 or more elements or compounds. Decomposition is like take M&Ms apart. They end up in pure chocolate and their covers are the food colorings. An example of which is the electrolysis of water, wherein there is a decomposition of water into oxygen and hydrogen gas. Third is single displacement, where a single element replaces an element in a compound. In this scenario, the cat's preference for milk over the ball of yarn represents the displacement of the element in the original compound. An example of which is when chlorine plus calcium bromide will form bromine and calcium chloride. Fourth is a double displacement, where an element from each of 2 compounds switch places. In this scenario, a cat with its box meets a dog with its basket. Both of them have an interest in each other's toy, so they decided to exchange their toys. An example of which is when sodium sulfide solution is mixed with hydrochloric acid, the components react, forming sodium chloride and hydrogen sulfide. Fifth is combustion, where a hydrocarbon, a compound containing only carbon and hydrogen, combines with oxygen to form carbon dioxide and water. For example, the bonds in the methane and oxygen come apart. The atoms are arranged to form water and carbon dioxide. We can therefore conclude that chemical reaction not only happens in a scientist's laboratory, but most importantly in an ordinary person's everyday life. We actually encounter one daily, but may just not notice. Try and be watchful of your surroundings and be fascinated with chemical reactions you may encounter.
Created using Powtoon.